All right, so this is Unit 2, Day 4a. We're going to look at the real zeros, and that just means zeros that are real numbers. So we're not going to do any complex, no i's, nothing like that. But we could have some radicals, could have whole numbers, could have fractions, because those are all real numbers. So we're going to look at the real zeros of polynomial functions. So learning target, I will understand the factors of a polynomial indicate the zeros of the function. We talked about that a little bit a couple days ago. That if it is the factor, then x minus 2, that means 2 is a zero of the function. So here's a quick little warm-up. It didn't give you much space, and I apologize, but given that -5, -3, and -2 are all zeros of a polynomial function, write an equation in standard form for the polynomial. Okay, so what we need to do, we're going to write out our, I'm going to stop there too. So this part, what if that, I'm going to hold on to that for a second. So the polynomial, we could just put, call it f of x. If -5 is a zero, that means x plus 5 would be a factor, x plus 3, and x plus 2. Now, to save you some time, if you multiply this all out, that's going to equal x cubed plus 10x squared plus 31x plus 30. Okay. Now, let's keep going with that. This is, what if the polynomial had 0, -60 as a y-intercept? Does this one have that as a y-intercept? So if you ever want to find the y-intercept, plug 0 in for x. So if I plug 0 in here, 0, 0, 0, those will get wiped out, and I get 30, which is not -60. So now, this isn't quite the right function. What I'm doing here, it looks like there's some sort of vertical stretch, vertical flip. Something's going on where my y-intercept, instead of being 30, is now -60. So what I'm going to do is I'm going to throw an a in there. I'm going to say that my f of x equals a times all of this. And now plug it in. So if I plug in 0, I should get 60. So 60 equals a 0 plus 0 plus 0 plus 30. Sorry, this is -60. So 30a equals -60. If I divide by 30 to try to find a, that means a is -2. So some -2 on the outside. When you plug that in, that's the one I'm looking for. Again, we're getting squeezed here on room, but so f of x is going to equal, I'm going to take -2 and distribute it. Because the a is -2, now I'll distribute it out to all the parts. So it'll be -2x cubed minus 20x squared minus 62x minus 60. This guy right here has those as zeros, and that's the y-intercept. Okay, and you can put it on a calculator, and you can check it if you want. It's up to you. You can trust me if you want to. Some theorems here. So theorem for a polynomial with real coefficients and any real number c, again, this is real number c, all the following are logically equivalent. These 5 things are saying the same thing. X minus c is a factor. If that is true, then that means p of c is 0. So up here, x plus 5 was a factor. What was I subtracting? -5. -5 is a root. Okay? If x plus, or if it was x minus 3, then when I plug in 3, I'd get 0. C is an x-intercept. That means the same thing as a 0. It is a 0. That means the same thing as this. And now here's one. The remainder, when p of x is divided by x minus c, when you divide them, if it's a factor, the remainder is going to be 0. It's like if I ask you to take 32 divided by 4. 4 is a factor of 32, so the remainder is 0. If I said take 32 divided by 10, the remainder would be 2. 10 is not a factor of 32, so that would not be true. Okay, so let's go down here. We're going to apply this idea. Okay, so look at this. This guy right here, I've got x squared plus 4x minus 12 equals 0. So if that is true, we want to look at some things here. So first off, let's factor it. I've got, what would be x? So the product's -12, the sum is 4, so that'd be what, plus 6 and minus 2. So that tells me, let's do this one. I'll do this side first, and I'll put that one there. It's going to get a little trickier. Not really, but a little bit. So x minus 2 is a factor. P of 2 would equal 0. So if I plugged 2 in here, 2 squared is 4, plus 2 times 4. 2 times 4 is 8. 8 plus 4 is 12. 12 minus 12 is 0. Oh, it worked. Shocker, right? 2 is an x-intercept. 2 is a 0 of the function, because when I plugged it in, I got 0. And if I divided the remainder, when p of x is divided by x minus 2, the remainder is going to be 0 because it's a factor. Now over here it says minus, what would this guy be? Would be negative 6. Okay, so x minus negative 6, because that became x plus 6. So x minus negative 6 is a factor. We just know it as x plus 6. If I plugged in negative 6, I'd get 0. Negative 6 squared is 36. Minus 4 times 6 is 24. Minus 12. Yep, that equals 0. Negative 6 is an x-intercept, and it's a 0 of the function. And if I divided by x minus negative 6, I would get 0. Okay? So all these things are equivalent. They all mean the same thing, basically. Let's see, example number 1. Our goal today is to find, or to solve polynomial functions. So let's look at this function right here. If I said, go ahead and factor it, that is not going to be very easy. Okay, and if I'm looking at it right now, I don't see anything that works for factoring. You know, we could, there's a thing you could call it factored by grouping. That doesn't even work with this. I don't know if you remember factored by grouping at all, but that doesn't work, so I'm not even going to show you on this one. So what we need to do is, I can't just see it, so I could actually narrow it down to a list. I can narrow it down. So here's our steps. List all possible rational roots using the rational roots theorem. This rational roots theorem is going to give you some possible roots. They're not all roots, but somewhere in there, if it has a rational root. So if the function has a rational root, it'll be in this list. This list may give you some false ones, but it will find a positive one if it exists. Okay. So given a polynomial of this, so let this be a. So a is 2, b is the last number, so b is 30. Any rational root will be the factors of b over the factors of a. So what I'm going to do, I need to list them first off. So factors of b, so factors of 30 would be 1, 2, 3, not 4, 5, 6, not 7, not 8, not 9, 10, not 11, well, we can kind of skip ahead here to 15, and then 30. Now, the tricky part of this is these are all positive numbers. So if I took 1 times 30, I get 30. But what if I had negative 1 times negative 30? That also equals 30. Or if I had negative 2 times negative 15. So I can't just put the positives, I got to put plus minus for all of these. That's where this plus minus is coming in. Because you could do 2 negatives also, so it's all plus minuses. So plus minus 1, plus minus 2, plus minus 3, and on. Now I got to write all the combinations of those over the factors of a, which is plus minus 1 and plus minus 2. So now I'm going to write all the combinations of the quotients. So I'm going to put all of these over 1 and then put all of these over 2. If a number repeats, you don't have to write it twice. Okay. Now if I put all of these over 1, I'm just going to get a repeat of that list. So plus minus 1, plus minus 2, 3. Okay, now I got to put them all over 2. So 1 over 2 would be plus minus 1/2. 2 over 2 is 1. It's already in the list. 3 over 2. All right, I apologize. My computer ran out of space during the recording, so I kept talking and it stopped recording. So I think where I left off might have been here. So 3 over 2, I did 3 over 2. 3 halves, and then 5 over 2 was 5 over 2. 6 over 2 is 3, which is in the list. 10 over 2 would be 5, which is already in the list. 15 over 2, and then 30 over 2 would be 15, which is in the list. So now, I've already said all this, but I didn't realize it wasn't recording. Somewhere, if there is a rational root, So it may not be true. This may not have any rational roots, but if it does have a rational root, it's one of these numbers, somewhere in here, okay? So let's flip this guy over, and we're going to check a few of them, okay? So we're going to use synthetic division or the remainder theorem. So these are two things we're going to use here. The remainder theorem says that when you plug it in, if the remainder is 0, then it's a function, or I'm sorry, then it's a factor. I'm sorry, it's a root. If I can get my stuff straight here. So it is one of those rational roots. Okay, so if I plug it in, I get 0. It's this idea right here, the remainder theorem. When you plug it in, it's a 0. So what I could do is I'm just going to kind of cheat a little bit. 1 is one of them, so I'm going to just show you what happens when I plug in 1. So this would be 2 times 1 cubed plus 2 times 1 squared minus 34 times 1 plus 30. And when I plug that in, so this would be 1 cubed is 1 times 2 is 2. This would be 2. This would be minus 34. This would be plus 30. So 30 plus 2 plus 2 is 34. Minus 34 is 0. So because of that, now I know 1 is a root. Okay, so 1 is a solution. So you could do that all day. Just keep plugging them in, and if when you plug them in, if it's 0, then that means it's a root. Another route here, again, that's because that was 0. Another thing would be synthetic division, which it has been a while. You had synthetic division in Algebra 2. It was before we got quarantined, quite a bit before. It might have even been in the first semester. But for synthetic division, I'm going to write down the coefficients. So it was a 2x squared, if you remember. 2, 2, negative 34, and 30. That's what I write down. We do want to look for descending power. So this is a cubed. If there's anything missing, then I need to put a 0 to hold its place, but there's nothing missing. There's a cubed, a squared, x to the first, and no x's, so nothing missing. So I'm going to put the coefficients here, so 2, 2, negative 34, and 30. I've already checked 1, so if I do 1, and I'm not going to find anything new. I already know 1's a solution. Let's try 2. Okay, so if you don't remember, for synthetic division, the first number always gets dropped down. Just drop that down to 2, and then you always multiply. So 2 times 2 is 4. That product goes right here. Okay, so this product is the product of those two numbers. Add straight down, multiply across. So 6 times 2 is 12. Fill it in right here. Add straight down. This would be negative 22. Multiply by 2, negative 44. Add straight down, negative 14. Now this number right here is a remainder. What does that mean? If it's not 0, that means 2 is not a root. So 2 is not a solution. So it's kind of up to you. These are two different tools to do the same thing. So it's not that you should do this followed by that, step 1, step 2. It's pick one and go with it. Okay, so let's do this. Let's synthetically divide by the root to get the polynomial to a quadratic function. So keep going to get a quadratic. We spent a whole unit on Algebra 1 on how to factor quadratics, how to find roots of quadratics. You've got, you could factor them. You could use a quadratic formula. There's all kinds of ways to do it. So we got a ton of experience with quadratics. So once we're down to a quadratic, that's good. So first off, the number we know is 1. So let's do that. Go like this. So 2, 2, negative 34, 30. I'm going to do 1. Okay, so again, drop straight down, multiply. Add straight down, multiply. Add straight down, multiply. Add straight down, I get 0, which that's good because that's confirming what we found out up here. Both ways say that 1 is a root. That's good. But the reason why I did that is because these resulting coefficients it's a new polynomial. So this is remainder, the constant, the x, and the x squared. So I got 2x squared plus 4x minus 30 left over. If I can factor that, I can find the rest. I don't have to keep guessing from that list. I can keep going with this, but boy, that's a lot to just guess and check. I kind of want to narrow it down. So once you find 1, you want to get down to a squared and factor that. So if I gave you this in the quadratic unit in Algebra 2 and said factor it, Well, they all are divisible by 2. Okay, now keep factoring. So what two numbers multiply to give me negative 15, add to give me 2? In this case, it would be plus 5 minus 3. And that means x would equal negative 5, 3, and don't forget the 1 we already found. So there's the 3 zeros to this function. Okay, and that's the amount of work it really took. Okay. Now, like I said, this way it's good for telling if something's a root, but then it doesn't, so what you found one, what do you do next? If you do this method, like we did here, synthetic division, we could use the result to keep going and factoring. It made it easier to find the rest. So use the same steps from above on this guy. So the factors of 24, plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, plus minus 8, plus minus 12, and plus minus 24. The factors of 2, plus minus 1, plus minus 2. So if I want to find all the possible combinations, so possible rational roots. Okay, I'm going to cheat a little bit. I'm going to say this whole list right here. So I'm going to say above, because that's what you get when you put all of these over 1. You just get to repeat that list. But now let's put them all over 2. So 1 over 2 would be 1/2. 2 over 2 is 1, which is in the list. 3/2, that's 2, that's already in the list. That's 3, that's already in the list. That's 8, that's 4, that's already in the list. 12 divided by 2 is 6, already in the list. 24 divided by 2 is already in the list. So it's this list plus these two are the possible rational roots. So let's try. So coefficients only, 2, 3, negative 21, 2, and 24. And let's try 1. It's always your first number to try, so drop it straight down, multiply, add straight down, multiply, add straight down, and then multiply, add straight down. Let's see, that'd be a negative 14, multiply, add straight down. That's not it. Okay, so that's 10. So 1 is not my guy. So let's try one that I know works. Okay, speed things up here. I'm going to just pick one that I know. So 2, 3, negative 21, 2, and 24. Let's try negative 1. Okay, so drop the 2 down, multiply, add straight down, multiply, add straight down, multiply. That would be 22, and then add straight down, 24, negative 24, 0. That's great. So that means that's one of my roots. And what I have left here, this is remainder constant x, x squared, x cubed. I'm not quite ready to just go straight to factoring. So I can actually take these and try 2. Let's see if 2 works. Drop the 2 straight down. 2 times 2 is 4. Add straight down. 10. Add straight down. Multiply by 2. 0. Perfect. So root, root. And now I've got, this would be x squared plus x minus 12. Now, let's try to factor those guys, because as soon as it's quadratic, try factoring. Okay, so this is going to be a little bit tougher. So 2x and x. I'm going to cheat and look. It's negative 3 and plus 4. I was trying to think about it. But so basically, these two have to multiply to give you negative 12, but then the outer plus the inner has to equal 5. Notice the sum of these don't equal 5 anymore, because that has a 2 out front. So in this case, this zeros, this would be a 3/2. This would be a negative 4. This would be a 2, and that would be a negative 1. So there's your zeros.